discuss about what are the different parts of the network functions, and at that we discuss about the what is driving point impedance and what is transfer impedance. So under this what are the basic two parts of the functions, that is the driving point and the transfer, and under that we have observed in terms of the impedance forms and the admittances forms. And then we discuss about the what is synthesis of the networks. That means under this synthesis we have taken the four different types of the networks must be there. So under that we have taken the what about the RL and RC and LC. Under that we have shown about the what is faster 1 and faster 2 and the cover 1 and cover 2 techniques. We discussed about the different techniques and we have do some problems depend upon this RL, RC and LC of fast 1, faster 2, cover 1 and cover 2. Now today we discuss about the what is Fourier series. What is Fourier series? So Fourier series means Fourier series are used in the analysis of periodic functions. Fourier series are used in the analysis of the periodic functions. So a periodic functions, many of the phenomena studied in engineering and science are periodic in nature. So the current and voltage in the alternating current circuit. So these periodic function can be analyzed into their constituent components by a process called Fourier analysis. What is the periodic functions can be analyzed into their components, that means fundamentals and harmonics, by a process is called Fourier transforms. So whatever we are to find and approximating using trigonometric functions for various square, sawtooth, etc. waveforms, they occur into electronics. So by adding more and more trigonometric functions together, the sum of these special trigonometric functions is called as Fourier series. Is nothing but the Fourier series are used in the analysis of the periodic functions. So these whatever you have taken the trigonometric functions like sawtooth waveform, square waveform, whatever the waveforms you have taken, these sum of these special trigonometric functions is called as Fourier series. Fourier series. So generally we know that the Taylor series, that is the representation of functions, are valid of those functions which are continuous and differentiable. They may be discontinuous periodic functions which require to express in terms of an infinite series containing sine and cosine. Whatever the Fourier series must be there, it will be in the form of the sine and the cosine waveform. So Fourier series, which is an infinite series, representation of functions in terms of sine and cosine terms. Sine and cosine. So Fourier series, which is an infinite series, representation of functions in terms of sine and cosine terms. So these Fourier series are in certain sense more universal than Taylor series. It is more universal than Taylor series, and it is always applicable for continuous functions, periodic functions, and also to the functions which are discontinuous in their values and derivatives. Where when you have to taken the Taylor form, when you have to taken the Taylor series representation, these are the valued functions which are continuous and differentiable. There may not be there are many discontinuous periodic functions. So in this whatever the Fourier series will be there, it is represent of such functions in terms of a sine and the cosine terms, and these series will be apply all continuous periodic functions, and also for functions which are discontinuous in their values and derivatives. So Fourier series is a very powerful method to solve ordinary and partial differential equations, particularly with the periodic functions appear at non-homogeneous functions. So this is the Fourier series is a representation in terms of sine and cosine terms. This is useful for both apply for continuous periodic functions and the discontinuous functions also, and this is a very powerful method to solve the ordinary and partial differentiation equations, particularly in periodic functions for appear for the non-homogeneous terms. So generally these Fourier series can be generally written as f of x is equal to of a naught plus summation of n equal to 1 to infinity an cos nx plus summation of n equal to 1 to infinity bn sin nx. So the complete Fourier series can be represented with values of f of, it will be represented in the value of the sine term and the cos term. So they have to general equation of this Fourier series is f of x is equal to of a naught plus summation of n equal to 1 to infinity an cos nx plus summation of n equal to 1 to infinity bn sin nx. So here their a naught, an and bn is some constant coefficient terms. How you find out this coefficient sum? When you have to find out that coefficients, what is the formula you get is where a naught is equal to 1 by pi integral of minus pi to pi f of x dx. So a naught is equal to 1 by pi integral of minus pi to pi f of x dx, and an is equal to 1 by pi integral of minus pi to pi f of x cos nx dx, and bn is equal to 1 by pi integral of minus pi to pi f of x sin x dx. So the complete, whatever you have to find out these terms, that is a naught, an and bn. So the complete equation will be f of x is equal to of a naught plus summation of cos n cos nx plus summation of bn sin nx. So when you have to find out this a naught, an and bn, a naught is equal to 1 by pi integral of minus pi to pi f of x dx, an is equal to 1 by pi minus pi to pi f of x cos nx dx, and bn is equal to 1 by pi minus pi to pi f of x sin nx dx. So Fourier series make use of orthogonality relationship of sine and cosine form. So in these equations we have to observe that this Fourier series will be in the form of the relationship of sine and cosine functions. So what is the basic formulas of this Fourier series means? The Fourier series of a periodic function f of s with period 2 pi is defined as the trigonometric series with the coefficients of a naught, an and bn, known as Fourier coefficients. It is called as Fourier. Already you have to write down the formulas of a naught, an and bn. So what is the function of the f of x with the period of 2 pi is defined by the trigonometric series with the coefficients of a naught, an and bn, known as Fourier coefficients, coefficients. So determine the bar formula. Already you have to observe what is the a naught in terms of integral of f of x dx, and an is in 1 by pi integral of f of x cos nx dx, and bn is 1 by pi integral of f of x sin nx dx. So the individual term in Fourier series are known as harmonics. What are the individual terms must be there? That term is known as harmonics. Every function f of x of period 2 pi satisfy the following conditions known as Dirichlet's conditions. Can be expressed in the form of the Fourier series. So whatever the periodic function f of x with the period 2 pi is defined as a trigonometric series with the coefficients of a0, an and bn are Fourier coefficients, and whatever the individual terms in the Fourier series are known as harmonics. So what are the conditions we have to observe? If f of x is bounded and single value, if f of x will be a bounded single value, then a function f of x is called single value if each point in the domain has unique value in the range. It has unique value in the range. A function f of x is called single value if each point in the domain it has unique value in the range. If f of x has at most a finite number of maximum and minimum in the interval, it has a finite value. What are the conditions we have find for the Fourier series means? If f of x is bounded on a single value, a function f of x is called a single value if each point in the domain it is a unique value in the range. If f of x has at most a finite number of maxima and minima in the interval, and f of x is a finite number of discontinuous in the interval. It is a discontinuous in the interval. What are the conditions? F of x is bounded on a single value and f of x has at most a finite number of maxima and minimum in the interval, and f of x has a most a finite number of discontinuous in the interval. So in suppose example sine inverse of x, we can say that the function sine inverse x cannot be expressed as Fourier series as it is not a single valued function, because we already tell that what is the condition, f of x must be a single value. So but here sine inverse of x, we can say that it does not be expressed as Fourier series, so it does not a single valued function. Tan x also in the interval 0 to pi cannot be expressed a Fourier because it is infinity at x equal to pi by 2. So tan x is also the interval from 0 to 2 pi, it also cannot be expressed as a Fourier series because it is an infinite at x equal to pi by 2. So next, Fourier series for even and odd functions. Fourier series for even and odd functions. Already these topics are already we discussed in the last sim. So once again I am telling about the what is Fourier series and what are the even functions and odd functions, how we find out the coefficients. So even function, if function f of x is an even periodic function with the period 2l. So that means minus l less than or equal to x less than or equal to l. Then f of x cos n pi x by l is even, while f of x sin n pi x by l is odd. N pi x by l is odd. So if function f of x is an even period function with the period 2l minus l to less than or equal to x less than or equal to, then f of x cos n pi x is even and f of x sin n pi x l is odd. Thus the Fourier series expansion of an even periodic function f of x with period 2l is minus l less than x less than l is equal to f of x is equal to a0 by 2 plus summation of n equal to 1 to infinity an cos n pi x by L. An cos n pi x by L. So n pi x by L is even, but sin n pi x L is the odd function. So f of x is equal to a naught by 2 plus summation of n equal to 1 to infinity an cos pi nx by L, where a naught is 2 by L infinity to 2 by L integration of 0 to L f of x dx, and an is 2 by L integration of 0 to L f of x cos n pi x by L dx, where n equal to 1 to 2 up to so on. And Bn is 0, because when you have to take in the even function, cos n pi xl will be considered and sin n pi xl will be the odd function. So Bn part will be 0. So the complete trigonometric Fourier series equation already we have to know. F of x is equal to of a naught plus summation of an cos n pi nx plus bn sin n pi x. So here we have to take in the L f of x with the period of 2L. So we have to consider f of x is equal to a naught by 2 plus summation of n equal to 1 to infinity an cos n pi x by L. So where a naught is equal to 2 by L infinity 0 to L f of x dx, where an is equal to 2 pi L 0 to L f of x cos n pi x by L dx, where L equal to 1 to infinity, and Bn is 0. And Bn is 0. And next one we have taken the odd function. When you have to take in the odd function, so here cos n pi xl by is even and sin n pi x will be odd. So here only we have to consider the Bn. So if a function f of x is the even periodic function with the period of 2L minus L less than or equal to x less than or equal to L, then f of x cos n pi x by L is even, where f of x sin n pi x L will odd. So thus the Fourier series expansion of an odd periodic function f of x with the period 2L minus L less than or equal to x less than or equal to L is given by f of x is equal to summation of n equal to 1 to infinity Bn sin n pi x by L. So f of x equal to summation of n equal to 1 to infinity Bn sin n pi x by L, where Bn is equal to 2 by L integration of 0 to L f of x sin n pi x by L n equal to 1 to. So when you have to consider even function, you have to find out a naught and an value. When you have to consider the odd function, when you have to observe only we have to Bn value, that f of x is equal to summation of n equal to infinity Bn sin n pi x by L, where Bn is equal to 2 by L integral of 0 to L f of x sin n pi x by L dx, as n equal to 1 to infinity. This is about the even and odd functions. We take a simple example how you find out the Fourier series. So find the Fourier series of f of x is equal to x squared plus x squared plus x. Solution. What is the solution? The Fourier series, generally what is the expression for Fourier series? F of x is equal to of a naught plus summation of n equal to 1 to infinity an cos nx plus summation of b equal to 1 to infinity bn sin nx. So when you have to find out using this formula, you have to find out a naught value, an value and bn value. So how we find out a naught? A naught is equal to 1 by pi integral of minus pi to pi f of x dx. What is the f of x value they given? X squared plus x. So 1 by pi integral of minus pi to pi f of x means x squared plus x dx. X squared plus x dx. So 1 by pi integration of x squared is equal to x cube by 3. And what about the x? X equal to x squared by 2. Integration of minus pi to pi. Integration of minus minus pi to pi. So what you get this for this? So an is equal to we get the value an is equal to How much? A naught is equal to 1 by pi x cube by 3 plus x square by 2 minus pi to pi. Next one. So for that you get 1 by pi, then you get pi cube by 3 when you have to substitute pi and minus pi, then plus pi square by 2 plus pi cube by 3 minus pi square by 2 is equal to 2 pi cube by 3 is equal to A naught. Now, an is equal to 1 by pi integral of minus pi f of x cos nx dx. So, what is f of x value? F of x is x square plus x cos nx dx. So, 1 by pi x square plus x cos nx, we get the sin nx by n minus x square is 2x plus 1 minus cos nx by n square plus 2 into minus sin nx by n cube, then into minus pi to pi. So 1 by pi into 2 pi plus 1 cos n pi by n square minus of minus 2 pi plus 1 cos n pi by n square. So we get 1 by pi into 2 pi plus 1 minus 1 in whole power n by n square minus of minus 2 pi plus 1 minus 1 whole power n by n square. So that is equal to 4 into minus 1 whole power n by n square. So a naught is 2 pi cube by 3 and an we get 4 into minus 1 whole power n by n square. Next, how you find out the bn? Bn is equal to 1 by pi integral of minus pi to pi f of x sin nx dx. So when you have to substitute f of x value is x squared plus x sin nx dx, then 1 by pi x squared plus x minus cos nx by n minus 2x plus 1 into minus sin nx by n square plus 2 into cos nx by n cube minus pi to with respect to minus pi to pi. So 1 by pi minus pi square plus pi by n minus 1 whole power n plus pi square plus pi by n minus 1 whole power n. So, minus 1 whole power n by pi into minus pi square minus pi plus pi square minus pi. So, we get 2 into minus 1 whole power n by n. So, from this, hence Fourier series of f of x is equal to x squared plus x. So, x squared plus x is equal to pi squared by 3 summation of n equal to 1 to infinity 4 into minus 1 by n square cos nx. This is a naught value, this is bn value. An value minus 2 into minus 1 power whole power n sin nx value. This is bn value. This is the expression when hence Fourier series of f of x, x squared plus x. Next, another problem when you have to find the Fourier coefficients corresponding to the function f of x is equal to 0, 3, minus 5 less than or equal to x less than or equal to 0 and 0 less than or equal to x less than or equal to x. Write the corresponding Fourier series. So, from this a period will be 2L and L equal to 5. Choose the interval C to C is plus 2L as minus 5 to 5. So that an is equal to 1 by L integral of C plus 2L f of x cos n pi x by L dx. So 1 by L is 5 minus infinity to 5 minus 5 to 5 f of x cos n by x by 5 dl. So when you have to substitute here 1 by 5 integral of minus 5 to 0 at the 0 cos n pi x by 5 dx plus 0 to 5 3 into cos n pi x 5 by dx. So for this you get 3 by 5 into 5 by n pi sin n pi x by 5. Anything with respect to the pi with respect to sine, we get the value will be 0. We get the value will be 0. So if n equal to 0, an is equal to a naught, that is equal to 3 by 5 integral of 0 to 5 cos 0 pi x by 5 dx. So we get here 3 by 5 integral 0 to 5 dx is equal to 3. Then what is the bn value? So bn value is 1 by L integral of c into c plus 2L f of x sin n pi x by L dx. So substitute L equal to C L equal to 5 and C equal to 5. So 1 by 5 minus 5 to 5 f of x sine n pi x by 5 dx. So for that we get 1 by 5 0 to minus 5 to 5 0 sine n pi x by 5 dx plus 0 to 5 sine n pi x by 5 dx. So here when you get 3 by 5 minus 5 by n pi, sine n pi x is equal to cos n pi x by 5. So we get the value that equal to 3 into 1 minus cos n pi by n pi by n pi. So for that the corresponding Fourier series is a naught by 2 is 3 by 2 plus summation of n equal to 1 to infinity. An is 3 into 1 minus cos n pi x by n pi sine n pi by 5. So that is equal to 3 by 2 plus 6 by pi into sine pi x by 5 plus 1 by 3 sine 3 pi x by 5 plus so on to 1 by 5 sine 5 pi x by 5 plus so on to sine pi by x plus 1 by 3 sine 3 pi by x plus 1 by 5 sine pi by x plus 1 by 7 sine 7 pi by x. Like that you get the numbers. So and another one thing, it will be half range Fourier sine and cosine series. This half range for sine and cosine series is a series which only sine terms or only cosine terms are present respectively. So in this half range series means there is only sine or there is only cosine terms will be present in the series. So when half range series corresponding to a given function, the function is defined in the interval 0 to L, which in half of the interval, and minus L to L, thus accounting the name of the half range. So the function is specified as odd or even. So it is clearly defined as other half of the interval, namely is minus L to 0. So one interval will be 0 to L, another one interval is minus L to 0. Either the half range frequency Fourier series means it is a series which only any sine terms or only a cosine terms. So an equal to 0, bn is equal to minus 2 by L integral 0 to L f of x sine n pi x by L dx for half range sine series. If bn is equal to 0, an equal to 2 by L integral of 0 to 2 f of x cos n pi x by dx for half range. If it will be the any one part, there is either will be the cosine or either will be the sine term. So when you get the sine term, n must be equal to 0. When you get the cosine terms, bn must be equal to 0 for Fourier series. This is about the half range Fourier series. Another, there is the complex form of Fourier series. For this complex notation, the Fourier series 1 and coefficients 2 can be written as f of x summation of n to infinity minus infinity cn e power I n pi x by L. So where c equal to minus L. Cn means 1 by 2 pi 2L integral of minus L to L f of x e power minus I n pi x by L. This is complex form of Fourier series. So in this discussion we discuss about what is Fourier series and what are the even and odd functions of Fourier series and what are the half range frequencies of Fourier series. So and for this Fourier series we observe the some problem depend upon how you calculate this Fourier series. Thank you.